Okay, we're talking about the rational zero theorem because we need a way to come up with what might be a zero so we can test it with our synthetic division to see whether or not it is a zero or not. And the problem is there's just a gazillion numbers out there you could test, so we really need a way to kind of narrow it down so we're only testing a few numbers. We used Descartes to help tell us there would only be, maybe two positives, so we know to stop after two, but we really didn't have an idea of what we should even start with. What number should we test? And, last section all we could do was look at a graph, and maybe that could give us a clue. But now we don't even have a graph to look at, so we're going to use this rational zero theorem. So let me put a function out here. So I have this polynomial, and I want to be able to find all the zeros. And honestly, I don't know where to start. So this rational theorem tells me to start testing some possible numbers. Okay, so the possibilities for rational zeros. So this doesn't help us with irrational zeros. It doesn't help us with complex zeros. It only is going to help us do rational zeros. And even then, this is a list of places just to test, okay? Not all of these will be zeros. But what it says is these rational zeros, if there are any at all, will come from this list. And you do the factors of the constant term, which I'm just going to go ahead and say the last number. So that would be the 4. That's my last number. It's the constant term. And divide by the factors of the first number, which is your leading coefficient. So here's my first number. Okay? And they also have to imagine that it could be a plus or a minus. So you need a plus or minus on that. So that's my sort of a shorthand notation for this rational zero theorem, that the possible rational zeros come from this list. So let's do this example. The list of possible rational zeros is going to be factors, there's my plus or minus, factors of the last number. So it could be a 4, could be a 2, could be a 1. Those are all factors of 4. Divided by the factors of the first number, which are only 3 and 1. So somewhere in here is going to be the numbers I test. This is a great way to write the answer, but for clarity, I'm going to write them all out so you know exactly what I mean by this sort of shorthand notation. So the list would include plus 4/3, plus 4, because that would be 4 over 1. The list would include minus 4/3, and the list would include minus 4 over 1. The list would also include plus 2 over 3, or plus 2 over 1. The list would also include minus 2 over 3 and minus 2 over 1. And finally, the list could include 1 over 3, positive 1 over 1, negative 1 over 3, and negative 1 over 1. So all of these numbers could possibly be a zero of the function that we started with. So every one of these numbers, we're going to test them and see if they are indeed zeros or not. And of course we test them with our synthetic division. Still a lot of numbers to try, but not as hard as, just shooting in the dark. Okay, so I have this polynomial, and I want to find all the zeros. I have no other information to go on, so I'm going to choose to make a list of possible rational zeros so I have something to test and just get started. So that list of possible rational zeros, that's a handful by itself, would be plus or minus the factors of factors of this last number divided by factors of the first number. So 9, 3, and 1. So what I'm going to do is I'm going to start synthetically dividing. I have 9, don't forget the 0, 5, don't forget the 0, negative 4. I like to start with the easy numbers. Okay? So what I'm going to do is I'm going to pick the easiest number is when you are dividing by 1, right? Those make the easiest numbers to synthetically divide with. So let's try that. I could put a plus 1 out here. So that becomes, bring down the 9, 9, 9, 9, 14, 14. Oh, I can see right now this is not going to work. Didn't work, so I have to try something else. 9, 0, 5, 0, negative 4. I have to start over. It's not like we can chain these together. And I have to start over because I had a failure, not a success with a 0 remainder. So I'm starting over. This time I'm going to try it with a negative 1. Because remember, I'm doing plus or minus all these numbers. Bring down the 9. Negative 9. Plus 9. Negative 14. No, this isn't going to do it either. So I can look ahead and see that it's not going to work. So that didn't work. That didn't work. Keep trying. Let's try another number. 9, 0, 5, 0, 4. Okay, so as you can see, I've tried every number possible over 1 with its plus and minus. I've tried them all, and none of them worked. I haven't gotten anywhere. And this is pretty typical. So I'm going to go to the next page, and we're going to keep trying. Okay, so I've just written everything down again, so I have it available. I've already tried everything over 1, so now I'm going to try everything over 3. This is my list of possible rational zeros. Alright, so let's try this again. And I'm going to have 9, 0, 5, 0, negative 4, and outside, let's start with 1/3. Okay, you can see 1/3 didn't work, so I'm trying negative 1/3. Okay, didn't work. Keep trying. Oh, Lord. Praise the Lord, I got the right answer. Everybody in my study hall thinks I'm crazy. Okay, but it worked, and I'm so excited because I finally got the right answer. 2/3 is one that gave me a 0 remainder. That one is definitely going to be a 0 of this function. I'm as happy as can be. But then I have to find more, right? So keep trying, but this time I can chain it, okay? So now, finally, I can chain it. So minus 2/3. Goes after that, because I did have my nice 0 remainder. So let's try it again. Now bring down the 9, negative 6, 0, 0, 9, negative 6. Oh, lo and behold, I have gotten 2 in a row. So, like, I'm on a roll. Take me to Vegas. I'm happy. So I got 2 of my solutions. Now, here's a thought. I've got started at an x to the 4th. I've taken 2 zeros out already, right? So that leaves me with a quadratic, right? I have these 3 terms, there's 3 terms right there. That's a quadratic. I have 101 ways to solve a quadratic. So I don't need this guessing and testing baloney. I can just go ahead and use any of my methods for solving quadratics to get the rest of them. So I'm going to do that. So 9x squared plus 9 is equal to 0. We'll find my remaining zeros. So let's take a 9 out. X squared plus 1. Get rid of the 9. X squared is negative 1. So that tells you right there that none of these would have worked anymore, okay? Because the only 2 remaining roots are plus and minus I. Okay, so I found all my solutions. Let's put all the solutions together. X is equal to 2/3, negative 2/3, I, and negative I. Those are all my solutions.